Hello students, and welcome back to another study at video. Now today we are going to discuss a simple factorization of root polynomials. Now as you guys might have observed, especially for class 9 students, when it comes to factorization of polynomials, they're usually in the form ax square plus bx plus c. However, there are at times, right, where there are root polynomials, where either of the terms contain roots, a certain root, like maybe 5x square plus 9 root 6. Assume it as an example. We have a root here. And maybe the last term could be a root. Maybe something like root 8, root 18, root 12, etc. So when there is a root in the polynomial, right, students find it hard to factorize the root because you can express the root as a product of anything when it comes to the term. So today I'll be teaching you guys a simple factorization trick for root polynomials. Okay, so we'll start this off with a simple example. Let's say we have the polynomial x square plus 3 root 3x minus 30. Let's observe x square plus 3 root 3x minus 30. We can observe that the middle term has the coefficient as 3 root 3. This is a root. How are we going to factorize this? So first, let's take x square as an example. We'll factorize this through ax square plus bx plus c, splitting the middle term. So ax square plus bx plus c. Okay, we'll use this term as our factorization model. Firstly, when it comes to factorization this polynomial, right, we have to express the coefficient of the middle term as a product of the coefficients of the first and last term. Or to make it simpler, b coefficient of the middle term must be expressed as a form of a into c. What is a? 1x square or x square? X square can be expressed as 1x square. So a is 1. C directly we make it 30. Okay. So a is 1, c is 30. A into c is nothing but 30 itself. So b, the coefficient, we must separate the terms such that their product is equal to 30. Okay, so this 3 root 3x, we divide it into simply ax and cx. Okay, expressing b as a into c. Now, how are we going to separate this middle term? We have understood that the product of the two factors we're obtaining here must be 30. But how are we going to separate this root? I'll teach you guys a very simple trick for it. Okay, note this with high concentration. First, cancel out the root in both the factors. Okay, assume this is a term, yeah, 3 root 3, we're using it here. How do you cancel this out? See, when there's a root, right, we can't directly cancel out anything. But if we recognize something, we know a root into root is the square, or a square root and square root multiplied is just the number. So you say root 3 and root 3. What do you get? 3, no? So similarly, when you multiply these two terms, you directly get 3. So you can directly cancel out the root. See, this can be made into a root 3 and c root 3, right? Upon multiplying both, you get root 3 and root 3 multiplied is 3. So, since we have separated the root 3, a root 3 and c root 3, we multiply it and divide it into a into c. Okay, so we know a into c is 30, right? When you multiply the root for both of them, what do you get it as? 3. So, you divide that 3 with the 30, or the remainder that you get after multiplying them. Root 3 into root 3 is 3. Divide that and you get 10. Meaning, after cancelling out this root 3 over here, right? I'll explain it with a short diagram here. After we remove this root 3 from the term by expressing it over a root 3 and c root 3, we get 10. Meaning, you see this main term over here, 3. This must be expressed as factors of 10. Understood? Let's move on to the second part of it. Now, what are the factors of 10? 5 and 2, 1 and 10. Upon clear observation, what do you see? 3 is nothing but 5 minus 2. So, the remaining 3, that part of the term, right? Make it into 5 and 2, 5 minus 2. So, 3 root 3 is nothing but 5 root 3 and minus 2 root 3. Very simple. See, once you cancel out the root, you get a term, right? Make it into a factor and whatever simplifies it, take that. It's that simple. So when you replace the 5 in a root 3, you get ax is nothing but 5 root 3x, and minus 2 in c root 3 is cx is minus 2 root 3x. So we split the middle term successfully. After this, it's pretty simple by itself. Okay, so this is abruptly seen 5 root 3x and 2 root 3x. You observe there's only one common in the first term, that's x. And then here, right, 30, since it's nothing but 2 root 3 into 5 root 3, which we already found out through the previous examples. Why don't we directly take out this 2 root 3 from these two terms? See, from these two terms, we managed to take out x. So these two terms, since we have already simplified this as a product, what do we get directly over here? We then directly take out the 2 root 3. So once you take out that 2 root 3, what do you observe? Both the terms have same, x plus 5 root 3, x plus 5 root 3. Take these and you get x plus 5 root 3 into x minus 2 root 3. So the final answer is x plus 5 root 3 into x minus 2 root 3. Very simple term. So I've used this example over here, but in case you generally want to know, cancel out the roots or make the roots into the similar terms. Okay, like let's say root x something, okay, y root x, make it into maybe let's say the terms are a and z, so a root x and b root x. After this, what you have to do is make sure that you express y in a means that it is a factor, like this y, you get it, okay? So this must be the product of a and b, or a and b's factors must align with this. Similarly, how 10 factors of 5 and 2, the factors of this should be equal to y. So as soon as you get that, replace the values of a and b, and then you can directly factorize it in order to receive the final answer. So I hope this was understood, guys. Thank you so much for watching, and in case you have any doubts, please message me in the comment section and I will instantly reply to it. Thank you so much. Have a wonderful day ahead.